All right. Hey guys, Miss Smith here. I'll wave hello. I'm going to be going over this question right here. So this is our learning target for today. And we're going to try to figure out how many triangles can I make if I know 3 sides. So we're going to take a break from angles for a minute. I know we've been doing a lot with angles, but we're going to talk about 3 sides of a triangle. And I have a line right here so I can answer my question when we're done at the end and we can discover it. But I'm going to have you take a guess first. So I'm going to pause myself here and I'm going to have you guess, how many triangles do you think I can make if I know 3 sides? All right, so hopefully your answer was 1, and I'm going to go over why your answer should be 1. What I have right here is a pile of different sides. All of these orange ones here are going to be a length of 5 units. The yellows are going to be a length of 4 units. And then these blue ones here are going to be a length of 3 units. And I'm going to go through all the possible scenarios for how we can determine that there's actually only 1 triangle. So I'm going to start with my 5, and I'm going to start with it going vertically like this. I'm going to put on my 4 on top and my 3 on the bottom. And you're going to say, well, Miss Smith, that does not make a triangle. I know. So I'm going to see if I can rotate these to turn them in and make a triangle, and if they're actually going to connect. So there they are. I have them connect. And I'm going to play kind of devil's advocate here. Well, Miss Smith, what if it matters if it's blue on top or blue on bottom, yellow on top, yellow on bottom? Do you think this is going to change the triangle that I make? I'm going to give you a chance to guess yes or no. All right, so just because I switch which one is top and bottom, no, it should not make a difference. I'm going to do my same rotation here. And even though those triangles look slightly different, I'm going to pull them together at the end so that we can look at all of these triangles all together. So you might be thinking, well, you know, Ms. Smith, you started with 2 oranges going vertical. What if instead you actually start with 2 of the yellows going vertical? Maybe that'll change it. Maybe if I start my pattern a little bit differently, I still need an orange and a blue. I guess I should scoot this over a bit here. I'm going to turn, that one was a little bit easier. I'm going to turn that guy in there. I need another orange and a blue because again, I started with my yellows being vertical. And I'm going to turn, oops, I got 2 oranges there. I'm going to start with these 2 lengths. I'm going to turn them in. And I'm going to, oops. It's all right, well, I'll make mistakes here. I forgot I need to switch my orange and my blue, my top and my bottom. So remember on this one, these are different because I'm starting with them orange on top versus orange on bottom. So I'm going to have you look at these. Do these 2 triangles look the same or do they look different? I'm going to give you a chance to guess here. All right, so while they do look slightly different, it's just their orientation that are different. They are not actually any different. They are exactly the same. I'm going to run through with this last one here. If these are now my heights, what happens when I have orange on top, orange on bottom, yellow on bottom, yellow on top, and I'm going to turn these the same way I did the last ones. And right now you might be thinking, Miss Smith, these all look like 6 different triangles. Do you agree or disagree that these are all 6 different triangles? Or I guess I should not agree or disagree. Do you think these are all 6 different triangles or 6 same triangles? All right, you should have picked that these are the same 6 triangles. And I'm going to try to orient these in a way, maybe with blue on the bottom. So all I'm doing is spinning them around. And in 8th grade math, you're going to call this a rotation. It is one of the translations that you're going to learn about. But what we're doing is we're taking the shape and we are just rotating it around. And I did it so that all of these would have blue on bottom. Okay. So now I can see a little bit more how they are actually all the same triangle, and I can even do a different rotation where I'm keeping both of my vertices the same, and all I did was flip them. Okay. So hopefully you can see that all of these are the same 6 triangles. Their orientation was all that's different. But if I'm given 3 side lengths, I can only make 1 triangle. It's just going to change which direction it's going. And one last quick question. What kind of triangle do you think this is? We don't know anything about angles, and I don't have a protractor here with me, but I think that you can use your observant skills to determine what type of angle triangle is this. All right, you should have picked that it is a right triangle. This is actually a special triangle. When you get to 8th grade math, you're going to look at a 3, 4, 5 triangle. So it does have a name of 3, 4, 5. And now I want to go and answer my question. The question we started with is how many triangles can I make if I know 3 sides? Even though I have 6 triangles, I can only make 1 unique triangle. I can transform it and move it around in different ways, but my answer for this one is if I know 3 sides, it can only make 1 unique triangle. All right, and with that, we will end our video. Thanks.